Assalamualaikum and greetings. My name is Mohammad Aiman Afif bin Asmat, Alam ID 019088, and I'm from DME 43 Delta. In this video, I want to explain about how I do my Solidwork project and the process. Okay, before I starting and proceed to the project itself, I will turn off my camera first to avoid any interruption while I explaining. Okay, as for the first part of my project, I do the pillow block first, or the housing of the bearing. Yeah, as you can see. Okay, as you can see, and in the first part, I starting off by doing the base of the pillow block. If you can see from the sketching, so the first thing I do is that I draw a center rectangle, and I put the length of it is 140, and I let off the width, let off the height first. After that, I draw a line connecting from the right side and left side. I draw two lines connecting the right side to the top side of the rectangle. Same goes to the right side to the top of the rectangle. After that, I put the dimension at the right side, which is 12 mm, both right and left side. And then I put the line length is 33.550 mm. And then I use the equal function with for both line here and here. And as for this, I to make the foot of the base structure, I use 2 mm gap and 44, 45 each foot. To make the sketch fully defined, I make sure all of this is vertical and also coincident point. After that, I both extrude the sketching. Here, as you can see, I both extrude it from mid plane by 38 mm. So for the next part is that I do the gap here where we will put the screw or the connector place. Here what I do is that I use a thread slot from here to here. Then I put the dimension 21 mm. The radius for the curve here is 11 mm. And for the width is that I use 22 mm. And as for the right part for this left slot is that I use power trim and I trim the right side of the slot, the curve of the right side. And I make this coincidental. The point of the slot is coincidental. And then I draw a line here to make sure it is one available slot. After that, I draw a line here as to make sure I can use this line to mirror the entity. After I mirror, I extrude the sketching using up to next. Yeah. With no any specific dimension, I only use up to next and it will come up like this. illustrate molecular same as the upper side of the base. Moving on to the next step, what I do is the place where we will put the bearing. Here, as you can see, I use the for the sketching. First thing I do is that I draw a circle using the point here. I draw a circle and then I put the dimension 68 mm, and from the center to this center plane of the sketching I do 28 mm, and after that I draw a line from the circle to the end part before the slide here, and I use power trim to trim the remaining circle inside to make this structure to match this shape. And to make sure it's fully defined, I make sure this is tangent in case it's coincident. The point here is coincident and there is tangent line. After that, I put the dimension here 8.65. After that, I boss extrude the sketching from mid plane by 33.0 mm. Moving on to the next part is that what I do here is I draft the housing part for the bearing. You see here, I draft by 4.20 degree by using this as a neutral plane, and this is the draft base. After that, I do another draft, which is for the bottom part of the base here. For the neutral plane, I use the upper part of the base, which have a sludge, and then for the face to draft, I draft this and this. After the draft, all I do here is I cut extrude the middle part of the circle here to make sure that we have a place to put the bearing in. Here, as you can see, the extrude size, the circle size is 55. The diameter of the circle is 55. I do the sketching here and then I cut extrude the circle, the sketching here. After that, I do boss extrude here. This is the gap. The gap here is for the bearing. By using the same the same diameter from the extrude just now, and 49 degree for new circle, I extrude this gap. Here, as for this part, is that I cut extrude the bottom part of the base, or right and left foot of the base. I cut extrude it by 7 mm. As for this part, I cut extrude the bottom part to make this curve, both of this curve at the base of the spiller block. What I do here is that I draw an arc and then I draw a line. And this arc is that I do the radius by 100 mm from this point to this point by a 3 point circle up. Here, 3 point up. And I draw a line here and I mirror the entities. I mirror these entities by using this line. And then I cut extrude both of it. Cut extrude both of the sketching here. Through all. Here, as you can see, we cut this front and at the back part of the base. And I will not cut any of the base of the bearing because the draft we do I do just now. Okay, as for this revolve cut, the first thing I do is that I use the same midpoint of the circle we do for the extrude here and for the cut here. And I put the circle diameter 52.20. By doing this, I draw a line from the center up to down here. And then I use the power trim. Then I trim the right part. By using the sketching, I cut revolve this inner part of the bearing place where the bearing will be put to make sure there is a slightly curve shape here where it will be the place where the bearing, because the bearing will also have a curve shape. Yeah, as you can see there, the cut will not cut the upper part of the extrude, but it will cut slightly inside the housing itself. Moving on to this part, what I did is that I used extrude cut to cut a part of the inside, a slightly part of the inside the housing. I do the center rectangle from the midpoint of the circle here. And what I did is that I used power trim to trim the remaining of the line and left only this upper and down line. And then I use the 3 point arc and I draw a line here. No, I didn't draw a line here. What I do is that I convert both of these line to entities first. And after I draw this, I use power trim and I trim the remaining part to make sure this will be remain as one entities. Then I draw a symmetrical line to the midpoint of the circle, and I use this line to mirror these entities to the right part here. And then what I did is that cut extrude, I cut extrude the sketching by 9 mm. Line by 9 mm, I cut this. After that, I set a plan here, as you can see here. I set this plan in order to do the lubricant hole or the place where we want to lubricate the bearing. Yep. As you can see, the sketching here is a bit complicated. Here. What I did here is that I draw a line. I draw a line here. I draw this 1, 2, 3, 4, 5, 6, 7, 8, 9. I draw this 9 line. I starting off by this straight line. Go to the left side and then up, right, up, right, and then from here to here I just draw a line, bend towards the left and then bend to the right, then again horizontally right to connect this whole line. After that I put the dimension to make it looks like this shape right here. And as for this line, I use this line to revolve the sketching to make sure I got this shape after I revolve this shape after revolving the sketching. And here I cut extrude. I use cut extrude to make this the lower part of the here of the lubrication hole to make it looks like a nut shape. Yeah, as you can see, I only cut it by 3 mm, just as for this part. Moving on to the next step is that I cut extrude this part right here. I cut by 3 mm. 3 mm. I draw a circle by 3 mm here, and then I use cut extrude to cut it through here, through this part of the upper side of the pillow block. This is just for the lubrication part. As for the next part, which is the revolve placement, what I did is the lubrication hole cap here, which is just a one ball. All I did is the sketching. For the sketching, all I do is here, all I do is like draw a circle inside the upper part of the lubrication hole or the lubrication pot, and then same as the revolve cut inside the pillow block. All I did is I trim the left side after I draw a center line. After I draw a line from here to here through the main point of the circle, and then I just use revolve balls Yeah, by 360 degree, I revolve it to make it look like this. There's tiny hole inside here as a lubrication cap for the pot. Then moving on to here, what I do is I fill it uh, this side. I'm starting off by filleting this side, the edge of the pillow block foot, and then I fillet the housing part of the pillow block, and then the upper part of the base of this pillow block, which is right here, and to the screw part of the pillow block. After that, I use cut extrude. As you can see, I sketch a slot here. I use the stretch slot here. I use the stretch slot to do for the screw or the for the connection part. First, I draw from the midline to this part of this left side part of the pillow block, and then what I do is that I use the slot and I put dimension 6 for the side of the slot, and then I use 12 for this width of the slot. After that, I draw I put the dimension 55 degree from the center of the slot to the center of this center of the sketching, and then I draw a center line, and I use the center line to mirror this entity or the sketching or the slot that I did just now. And after that, I use cut extrude and cut it through all. Yeah, I cut it through all. This is for the screw part. And after that, I use fillet to fillet the inner side of the screw part, both up and also the bottom. Same goes to the same goes to the right side of it, at the top and at the bottom. This is all for the first part. Here is a drawing. As you can see here, this is the front, this is the right, and this is the bottom. Moving on to the next part, the second part, which is the ball bearing itself. As for this part, what I do first is that I revolve the place where the ball will be put in. I draw a I starting off by draw a center rectangle and make the center rectangle width center rectangle length 18 mm and the width is 2.5 mm. And then I draw a 3 point up here to here, and the arc radius is 24.5. After that, I use power trim to trim the side of the rectangle, and then I draw a circle here, I draw a circle here. The diameter of the circle is 5, and I use power trim to trim it. For the midpoint of the circle, the midpoint from the midpoint of the midpoint circle to the midpoint of the sketching is 21 mm. And after that, I use revolve course. It turns out like this. For the second part is that I do the ball here. I make the ball here by sketching it through here, through inside the gap, inside the outer part of the bearing. I draw a circle, and the diameter of the circle is 5. I use power trim to trim the left side, and I draw here symmetrical line, a straight line from up to here through midpoint of the circle, and the midpoint of the circle length to the midpoint of the sketching is 21 mm. After that, I use this entity to revolve this entity to make it make a ball, to make a single ball here. After that, I use circular pattern. Yes, you can see here. I use circular pattern by using this inner of the outer part of the bearing as a face, as a direction, 360 degree, and the total of the ball is 22. Yeah, there's a total of 22 balls inside this bearing. And after that, I make the inner part of the bearing. For this inner part, what I do is that I draw a rectangle shape from here to here. I draw a circle by using the same dimension as the ball to make sure it fits perfectly with the ball. As for this, for the length is 4 mm. The sketching, the gap from the outer part here drawn here is 15 mm, and the bottom part to the center of the sketching is 16 mm. After that, I use revolve by 360 degree to make it looks like this. As for the next part, what I do is that I make the cover, the front cover of the ball bearing. As you can see here, this is the front cover. What I do first is that I convert this line as an entity, and this line, I make sure I draw a line by 43.7 degrees and 43.7 mm as for the diameter for the cover. And then I both extrude the sketching here. I both extrude the sketching here by 0.5 mm. This is for the front cover. As for the back cover, I mirror it. I use the center line. There should be a center line here. Here, I use the center line here, and I mirror it through here. As for the next part, I use the chamfer feature to chamfer the front side of this bearing and also here. And I also chamfer the inside of both sides of this bearing. And after that, I make this hole right here for the bearing where this is the port to secure or put a screw or nut to connect it with the shaft. I draw the circle by 5 mm diameters and the center of the rectangle of the circle to the center of the sketching is 18 mm. After that, I do a circular pattern to make 3 holes. Here. For the direction, I use this edge and then I put the total number of the circular pattern that I want is 3 by 360 degree, and it turn out like this. There will be 3 hole or port for the screw to connect it with the shaft. This is for the bearing, and I chamfer the hole from both inside and outside for all three hole of this bearing here. This is the sketching for my ball bearing. Moving on to the assembly part. For the assembly is that what I did, I insert both of the component, both of the part 1 and part 2. I insert it inside this ball bearing, and what I did is that I made the inside part of the outer. I made the outer part of the ball bearing and the inside part of the pillow block. After I made it, I made again this side to this side to make sure it's perfectly made. And this is all for my Solidwork project, which is ball bearing. As you can see, the bearing is fully rotational. Fully rotation. This is the lubrication part, the screw part, the ball bearing is inside. There is cover, and the hole is for screw or any connection to connect it with the shaft.